Hello everyone, myself Venu, lecturer in mechanical engineering from Government Polytechnic Varangal, and subject dealing is refrigeration and air conditioning. And today's video lesson, today's topic goes on evaporative condenser and expansion devices. So just recall all the topics what you have seen in the last video class. So hope you have seen the last video class, that is regarding the condensers, the types of condensers, just depending on the medium, the factor what you are taken is depending on the cooling medium like air, water, or combination of both the two, air and water. So we have discussed the different types in that, and seen all the diagrams regarding that, and the explanation has seen on the types of the condensers also. Okay, so like air cooled and water cooled condensers. And so in this today's video class, that left out topic is evaporative condensers in the condenser topic, and further we are going to discuss the other topics also. So just we list out them, and in today's class you are able to understood, or you are able to know regarding the what is evaporative condenser, how it is getting functioning, and we will see some diagrammatic representation here, and we can explain regarding that evaporative condenser. And next we will see what are the comparisons between the water cooled and air cooled condensers, and next we move on to the next component. The main component in the refrigeration equipment is expansion devices. So we well know about expansion device, already seen the explanation regarding the VCR system. Okay, so we will see again what is the function of that, and what are the different types of expansion devices, and we will see them, the types, and we will see the principle of that and operation of that. Like next we will see the principle of capillary tube and thermostatic expansion valve. These two are the types of expansion devices. We will see the working of both of them, and we will see the line diagram of both of them, and at last, if the time persists, we will see the working of solenoid valve also. We will see that what is all these devices and all these equipments used in the refrigeration. So first we considered on the left out topic, that is evaporative condenser, right? So here, as already told, that depending on the cooling medium factor like air, water, or a combination of both the air and water cooling medium. So here whatever the evaporative condensers are there, so in this we are using both the cooling mediums like air and water. So both the mediums are utilized here, and the process happened in that is the water is getting evaporated in this process, so they are named as evaporative condenser. And when these type of condensers are utilized, it means when there is a scarcity of water, when there is scarcity of water or a little amount of water is available, then there we can go. Condensation is a prime requirement there, compulsory, it's a mandatory. So must and should, for a bigger equipment like this, it requires more amount of water. If not, you can go for combination of both the cooling mediums like air and water. So evaporative condenser, maybe if you look into the line diagram, you will get some idea regarding that how they are making contact with each other. Air and water, the refrigerant is making contact. So just we look here, just I told regarding when there is a scarcity of water, the insufficient facilities for disposal of water, so there we can use these type of evaporative condensers. So here this is a diagram. Here you can see, observe the components involved in the evaporative condenser. So for a while you can see all the components here. See, if you observe from the bottom, so at the base you can see there is a water tank where the water is collected in the water tank, and at the left side you can see air is flowing inside the section. From the bottom the air is entering, and other side of at the bottom you can see there is a pump is provided here. Okay, a pump is provided, so where the water is sucked from the water tank and it is sent into the further at the top of the section. I will show that. And here at every time in the water tank you have to additionally add some water in this. Why? Because evaporation of water is taking place. Light amount of water is getting evaporated. So whenever the quantity reduced in the water tank, additional water has to be added in that. That is a makeup of water. Okay. And now if you observe the connection of the pump, it is making connection to the spray nozzles here. Spray nozzles are provided. From that the water is spraying onto the whatever the tubing section is provided here. Now the tubing section, if you observe, there are two passages. One is the refrigerant is coming. So this is a condenser. So refrigerant vapor with high pressure and high temperature, it is coming from compressor. So this is a connection making to compressor. From the compressor, vapor refrigerant is coming and entering to the pipes, and it is flowing inside the pipes, and the refrigerant liquid will be come out liquid. So here the phase change is taking place, so it will come out. Now if you observe here, the water is making is the water with spray type of nozzles are there where with the spray they are forming like a thin film around the water, around the refrigerant tubes here. The refrigerant which is flowing inside the tube, the water is forming around the tube. A thin film of water is formed around that. Now what happens, heat exchange will take place between the refrigerant and the water water, whatever thin film is formed, so it will absorb the heat exchange will take place. Okay. Now to reduce the further whatever the heat absorbed by the water, so that heat has to be removed out. Why? Because again the same water is sending back through these spray headers or spray nozzles. So to reduce the temperature of the water, see the air is making contact over the tubes. Now simultaneously the temperature of that water will also reduces here, but a small quantity of water is getting evaporated during this process. And if you observe, so these are the components involved inside. And if you observe further above the spray nozzle, we are providing eliminators here. So the use of eliminators are whatever the whenever air is making contact with the water, with that hot water, that air is taking the heat from that hot water which is formed around the tubes. And now the water is getting cooled. A small quantity of moisture is present in the air, so that it is taken by the air and moving upwards. Okay, whenever it is moving, some eliminators are provided here to avoid the water particle moisture content which is there. So it will make contact with the eliminators, and small quantity of water moisture will be accumulated at that part, and the water will come, that water droplets will fall down again. Okay, so just to avoid the air along with the moisture, so the moisture is arrested there, and only air will be sucked through the eliminators. So this happened in the eliminator process. And further to suck the air which is moving upward, here must and should one arrangement is provided here. The fan is provided, so it will suck the air in the section, in this inner section. Now the air which is sucked, it will be sent outside again to the atmosphere. So this is explanation regarding evaporative condenser and how the heat exchange is taking place between the refrigerant and the water film which is formed around the tube. Okay, just we look at all the points here. So here this is the points you can read out now. Air is drawn from the openings provided at the bottom with the help of induced draught fan. Now how the air is coming inside the section means, it is also one reason. Whatever the fan provided at the top, that is a draught fan, that it will suck the air. Whenever it is rotating, it is sucking the air from the vent provided here, or the passage provided. Passage provided is at the bottom. Now air passes over the coil, over the refrigerant coil and water spray. It may contact with the water spray as well as the refrigerant coils also. Now so water is sprayed through nozzles with the help of pump. I already explained that. And water forms a thin film of water on the surface of the refrigerant coil. So whatever the coil is there here, around that thin film of water is formed around okay, around the tube. Next, so refrigerant rejects heat to water, as heat exchange takes place between the water as well as the refrigerant. Now Simultaneously the water rejects the heat to air in the form of evaporated water. So whenever it is making contact with air, so it receives some moisture content from that evaporated water. In the form of evaporated water will move upwards. That vapor refrigerant condenses to liquid and it will be collected through the other passage provided here. Next, eliminator is provided above the spray header. So it is placed above the spray header and the purpose is to stop the water particles from escaping along with the discharging air. So already explained that whenever it is escaping along with the water particles, so it will um, stops that water particles and again it will come, it will falls down into the water tank here. So here the water is circulated with the help of pump which collects at the bottom of the water tank. Okay, right. And next, if you observe, water is added to compensate the loss of water due to evaporation. As I already explained, the makeup water is added at every time, but because evaporation process is taking place due to addition, making the water, hot water along with the air, moisture content of along with the water vapor is carried by the air. So water is level is reduced in the water tank. So the loss of water due to evaporation has to be added at every time. That is makeup water. Okay. So hope you have understood that explanation regarding the evaporative condenser, where we are using both the yeah, the type. It means cooling mediums, the air as well as the water. Okay. Now, so hope you understood the topic, and coming to the next topic, that is regarding the comparison between the water cooled and air cooled condenser. So here, uh, coming to the first point regarding the water cooled condenser, just a very simple differences you can identify that. So initial, as the water has to flow, the design, coming to the design, whenever the water is flowing inside the condenser through the pipes, so the design may be somewhat complicated, and the material used in that it should be non-corroded, and some properties has to be followed further. So must and should the initial cost and maintenance cost are high, whereas in the air cooled condenser it is very cheap and maintenance cost is also very low. So here additional pipes are required for water, so no piping work is involved here. Okay, so whenever water has to flow inside the tubes, like pipes are used, there is a need of using the pipes to flow the water inside that, so additional pipes are required there. So here for air cooled it is a open type and no piping work is involved for that. And coming to third point, the disposal of water is difficult here, right? That is one of the main problem. Whatever the water is circulating, so it has to dispose into the some other component and it get cooled and again it is supplied back to that. So it is a somewhat difficult disposal of water. So no problem of disposal of directly it is exposed to the atmosphere directly, so no need of any problem in the air cooled condenser. Next, coming to water cooled condenser, the point is corrosion occurs inside the pipes and more fouling effects. So whenever like a surface is very soft and some foreign particles will deposit inside the pipes and some fouling effect will take place, material may get wear out, further the fouling effect is there, and there is a problem of corrosion at some other time. Compulsory water will give more corrosive effect to the materials. So somewhat costly materials or some non-corroded materials has to be used, so which will increases the cost of that particular the water cooled condenser. And here, whereas in air somewhat some moisture content is present, but compared to that water cooled condenser, the corrosion and fouling effects are negligible in this. And coming to the function, high heat transfer rate can be seen in the water cooled condenser, whereas here low heat transfer rate can be seen in the air cooled condenser. So right, obviously this water cooled condenser used for large capacity plants, and for air cooled condenser it is used for small capacity plants. So as the volume of that particular air is more, and system water it making contact with that is it doesn't suit for the larger plants, larger capacity plants, whereas if you see the water, the density of that is very, compared to air is less, it makes more contact with that, and it requires for larger capacity plants. Next, observe the next point, that is silent in operation in the water cooled condenser, as no use of additional equipments there, since the water has to flow inside the tubes, that's it. Whereas in the fan, if you take like air cooled condenser for more than 1 ton, like that, at part of 1 ton, also 1 ton refrigeration capacity plant, we have to use, when the condenser is made compact there, the fins has to it has fins components are also reduced in there, so we have to use the forced air cooled condenser. So for forced type, must and should have to place the fan there, so there is a noise production will be there, noisy operation is there in the air cooled condenser due to that condition. And in the water cooled condenser, it is a low flexibility. It means it is a like a what I have told, that the design complicated is it is a very complicated, and you see all other factors, like the water discharging problem is there. So compared to the air condenser, flexibility is very less in the water cooled condenser, right? So that is the one point. Next, if you see the third point, even distribution of water on the condensing surface area. So as already told that, so it is all the where due to its density more compared to the air, even distribution of water on the condensing surface area will take place. So it may contact at each and every point there, so more cooling effect, more heat transfer will take place. Whereas here, uneven distribution of air on the condensing surface area, so sometimes the air may get contact at some other point, or some other point it may not get contact there. Like that, it will take place in the air cooled condenser. Handling of equipment is difficult here. Okay, handling of equipment is difficult in the water cooled condenser. No handling problems, just a simple fin and a tubing section is required for that, that's it. It's very simple in air cooled condenser. Okay, so this is regarding the comparison between the water cooled and air cooled condensers, and that evaporative condenser. So this is the part for up to the so this is the part up to the condensers. The next, we move on to the next main important topic, that is expansion device. It is the third main component in the refrigeration equipment. So coming to that, what is the, just we call it with other names also, that is also called as throttling device, metering device, or mostly named as an expansion device. Maybe the construction may be different, but the functioning, whatever they're doing, is the same. Just we see here, uh, if you see the location, expansion device, so it's just after the condenser. You see, just after the condenser, main component is expansion device. But to collect the refrigerant which is coming from the condenser, that high pressure liquid, that has to be collected in one component, that is a receiver is placed there. Just to collecting purpose, we are placing the receiver. After to the receiver, that main component is placed, that is the expansion device, and that expansion device is placed before the evaporator component. Okay, so it is placed in between receiver and evaporator component, expansion device. Or in some cases, instead of, we can directly take it as it is placed in between the condenser and the evaporator, that is the expansion device. So separate high pressure and low pressure side of the refrigerating system. So separates in the sense, so up to, if you observe up to the receiver tank, the whatever the liquid is coming from the condenser is collecting in the receiver part. So up till enter to the expansion device, it is maintaining high pressure side. After the expansion device, it is maintaining the low pressure side. Okay, so expansion device is reducing the pressure here, if you know the function of that. It is decreasing the pressure rapidly, where the low temperatures are created at the exit of the expansion device, if you see there. So it will separate the system into two sides, that is high pressure system and low pressure system. So compressor, condenser, all the receiver will come under the high pressure side. There is the expansion devices and the evaporator component, all those comes under the the low pressure side of the system. Okay, next, so when we call it as expansion valves, means the expansion devices used with dry expansion evaporators. Okay, the expansion devices used with dry expansion evaporators are called expansion valves. Are called expansion valves. Now, expansion devices used with flooded evaporators are known as float valves. It means how we can identify that, means just to take a simple example of your refrigerator. It is a dry type of evaporator. It's a dry type of evaporator. It's not completely filled with any liquid or anything. So there at that part, here they can be called as the expansion devices or expansion valves. Or if you take with the flooded evaporators, we will see the types. What are the types? The dry evaporators, flooded evaporators. In the case of flooded evaporators, the expansion device, whatever they used in the float valves, known as float valves, are used. Okay. And this is the function of the expansion device. It reduces the high pressure liquid refrigerant coming from the condenser to low pressure liquid refrigerant before supplying to the evaporator. So hope you understood that. Reduces high pressure liquid refrigerant coming from condenser so to low pressure liquid refrigerant. So no phasing is taking place. Liquid refrigerant is remaining as liquid refrigerant. The pressure is reduced drastically from high pressure to low pressure, where it resulting to low temperatures are creating in the expansion device at the end of expansion device. So before it sending into the evaporator component. So supplies the refrigerant according to the load on the evaporator. So depending on the load also, so it will supplies the refrigerant. Right? Evaporator, more the components if you are placing in that, more the products, more the refrigerant has to be sent into the component. Lesser load is there, depending on that condition, refrigerant will be sent according to with the help of this expansion device. Okay, so this is regarding the what is the expansion device, what is the function of that. Next, moving on to the next further topic, that is types of expansion devices. We'll see that mainly. So these are the types of expansion devices. That is a capillary tube, the most used, very cheaper cost, and most functioning expansion device is capillary tube. Most of the very low capacity refrigeration equipments or refrigeration devices are there. So there we are establishing or using this capillary tube. Whereas moving on to the higher ton capacity, like 2 ton, 1.5 ton, 3 ton, 4 ton, so mostly we are using these thermostatic expansion valves or automatic expansion valves. So they are simply the another TEX, thermostatic expansion valve. The solenoid valve is also taken as a one type of expansion device. High side float valve. So float valve is under when, as already explained, when the type of evaporator is different, like flooded type of evaporator, there we can use the low side and high side float valves. Okay, so this is regarding that, but most we will discuss regarding the capillary tube and the thermostatic expansion valve. These are very important cases in the expansion devices and mostly used expansion devices. So just we look at the line, just we see the line diagram of that, the capillary tube. So what I have told that you can see a small diameter and larger length, a coiled tube which is there here at the left hand side, you can see. So that is capillary tube, and it is making connection to the evaporator. Here you can see the evaporator at the right hand side, where the evaporation is taking place in this. And here the liquid refrigerant which is coming from the condenser, that it enters into the capillary tube. Before the capillary tube, a strainer or dryer is placed here. Strainer or dryer is placed. As explained, what is the need of that strainer and dryer in the vapor compression refrigeration system. The strainer, it will just like a net type of structure is there, so where it doesn't allow any foreign particles inside the capillary tube. And if you take the dryer, so any other moisture content which is present in the liquid refrigerant, so that it will absorbs by the dryer. Some desiccant material is used inside that, so that it will readily absorbs the moisture content which is present in the liquid refrigerant. So if there is a problem, if you are not placing the strainer or dryer at this component before the capillary tube, so due to its very smaller diameter, very small, very minor diameter tube we are using there, if any foreign particles enter into that, may struck the, or it may completely choke um, the capillary tube, and it will reflect on the functioning of the system total, the refrigeration system. If you are not using the dryer also, there is a chance of a very minute amount of moisture is present in that during the charging of refrigerant, or during some other any other factors involved in that. Mostly during the charging of refrigerant, there is a light quantity of moisture will enters into the system, so that has to be removed. Now that dryer has to be placed before the functioning of the before running the refrigeration system. If the moisture enters into the expansion device, as I already told, that it creates very low pressures and low temperatures. That moisture, due to that low temperatures minus centigrade, moisture is nothing but a water particle, so that it will get choked in the very that in that capillary tube, which is having very minor smaller diameter. So it will chokes the complete passage of that pipe, and the refrigerant will not enter into the evaporator component. It will damage the system. So this is why these safety devices are important, the strainer and the dryer before the capillary tube. Okay, so this is a smaller diameter coiled tube you can see before the evaporator, that is capillary. Now just we explain regarding the capillary tube. So observe some points here. When you observe in the refrigerator, a smaller diameter tube is present, that it is connected in between the condenser and evaporator, or after the receiver and evaporator. It is a very smaller diameter and coiled and very high length, in between like a 2 meters or 2.5 meters length. You can see they are coiled together in a small diameter tube, that is a capillary tube. You can see there it's a constant restrictive type device. So merely a tube with a narrow area of flow. I already told that due to very lesser smaller diameter, the area of flow is a very narrow one. Okay, so we'll see here. So this is very important point. So how the pressure drop is obtained here, so that is due to heavy frictional resistance offered by a smaller diameter tube. So the very smaller diameter, what happens here, more the pressure drop will take place. That is the first thing. Second thing, due to its very smaller diameter, the whatever the frictional resistance offered, that high pressure refrigerant is flowing inside the tube, so more the frictional resistance is offered due to very smaller diameter. So inside the pipe, heavy frictional resistance, friction will take place between the material inside the component and the refrigerant. Okay, so that it is responsible to reduce to drop in the pressure, or pressure drop. Okay, next, it is also important point regarding for each set point of knowledge. The frictional resistance offered is directly proportional to its length. So more the length you are using, more the pressure drop is obtained there. Okay, so more the pressure drop is required, more the length for pipe. So here the frictional resistance offered is directly proportional to its length. More the length, more the resistance it is offered, more the pressure drop will take place, and inversely proportional to its diameter. It means length has to be more, diameter has to be less, diameter has to be decreased. It is inversely proportional. More the diameter you are decreasing, more the frictional resistance it is offered. Okay, so mostly it is used in domestic refrigerators, water coolers, and small commercial freezers. So as already told, for domestic usages and for a very less tonnage of capacity refrigerators, these capillary tube is used as an expansion device. Okay. Next, here the refrigerant enters the capillary tube So due to frictional resistance offered by small diameter tube, so the pressure drop will take place, and they may be used for small units up to 1 ton. So this is regarding the capillary tube, how the pressure drop will take place due to those two factors you remember, mainly due to the frictional resistance offered by the pipe. And further the design concepts are the smaller diameter tube is essential. Lesser the diameter, more the frictional resistance it is offered, and more the length, it's directly proportional to the length of the pipe frictional resistance, and it is inversely proportional to the diameter of the pipe. Okay, and if you see the some merits of capillary tube, that is it's a simple in construction, and no maintenance is required. The cost of capillary tube is less, leak proof device and easily repaired, so very easy to repair it is. And the system using this device does not require service valves and a receiver. Okay, no need of any receiver here in the system. So this capillary tube is very effective, um, and it doesn't require any service valves and receiver. Coming to the demerits, when there is a fluctuating loads in the evaporator, so they cannot be used here. Now the refrigerant must be free from moisture and dirt. Refrigerant is free from moisture, and why? Because as I already told, due to its very smaller diameter and long length it has to travel, so it must ensure the moisture and the dirt has to be removed with the help of the dryer cum filter or a strainer. We can use like that, dryer and strainer like that. And here other demerit is, otherwise just it will choke the tube, the same it results, it will choke the tube and stop the flow of the refrigerant. So this is regarding uh, the capillary tube. Next, other expansion valve is a thermostatic expansion valve. When we are going for the larger capacity plants, we can go for this thermostatic expansion valve. So this is the diagram you can see here. So where the components, please try to observe here in this. So there is, at the right side you can see there is a evaporator coil. So here you can see the entry of whatever the, you can see at the end here, at the left side of that you can see there is a box type of structure in which there is a components, like you can see some adjusting screw in that, making connection with the spring, and to that one a diaphragm is placed here. A valve and valve seat is provided here. A diaphragm at the top, a round type of a disc type of structure will be there at the top, and to that it is making connection to the valve and valve seat is there. Okay, and here and now you can see there is a strainer is also provided here at that part, and at the top there is a tube is a section, a tube is provided here, just like a capillary type of the pipe is used here. And at bottom you can see, so a bulb is provided here. Okay, in this bulb there is a refrigerant which is present inside that. And what happens whenever there is a change in the temperature, so it will be indicated in this part, and the pressure according to that it will be act over the at the top of the diaphragm here. So this is nothing but the bulb pressure you can see on the top of the diaphragm. So when the bulb pressure is more, you can see you will see in the point wise. So here the thermostatic expansion valve or TEX valve is designed to meet the variations in the load. It means if you observe the previous the expansion device, that is capillary tube, so it's the main demerit in that is when there are fluctuations in the fluctuations of load is taking place in the evaporator. So at that part we cannot use particularly when more the variations are there in the evaporator, that load variations, we cannot go for the capillary tube. So in that case we can employ this thermostatic expansion valve. And other name for this is known as a superheat valve. because, so you can have the sentence here, it maintains the constant superheat of the vapor refrigerant at the exit of the evaporator. You can see at the bottom the pipeline, you can see that is the exit of evaporator which is moving to the compressor. So according to the requirement of the compression process and evaporation process, here the refrigerant, it will enters into the compressor here. So during this entry, at the exit of the evaporator, you can see a feeler bulb is placed where it senses the temperature of the refrigerant which is flowing at the exit of the evaporator. So according to that, the pressure differences occur here. So that pressure will act at the on the diaphragm here. So there are three pressures going to discuss in this here. So it consists of a needle valve, a valve seat, a diaphragm spring. So you can observe in the diagram, and an adjusting screw is also there. So here at the bottom I have told that there is a feeler bulb. It's mounted on the suction line, or you can know that suction line is in between the evaporator and the compressor. With the pipeline, you can take it as a suction line. So at the exit of the, or at the outlet of the evaporator coil, a feeler bulb is placed. So in that bulb, the same refrigerant is filled in the bulb. So here the partly filled with the same liquid refrigerant used in the system. So whatever the refrigerant is there, which is in the form of liquid, so that it is filled partly in the bulb. Now the opening and closing of the valve depends on three forces acting on the diaphragm. I already told. So these are three forces has to be taken into account. So one which is acting on the top of the diaphragm, at the top you can see through this pipeline, acts on the top of that, and at the bottom you can see here. So here you can see here the pressures, the P1, P2, which is acting the below the diaphragm, and P3 pressure is acting on the top of the diaphragm. We will see what are those P1, P2 and P3 formulas. So here since spring pressure P1 acting on the bottom of the diaphragm, so whatever the spring is there, so that pressure or whatever the force, it can be taken as a P1 here. Next P2 is the evaporator pressure, the inside the refrigerant which is there. So that refrigerant pressure is P2, which is acting on the bottom of the diaphragm. So both the pressures P1 and P2 are acting on the bottom of the diaphragm. Next the feeler bulb pressure, what already told, when there are temperature differences occurring here, so that pressure P3 acts on the top of the diaphragm. So here the pressure feeler bulb P3 act on the top of the diaphragm. Next so here the pressure combination can be taken. It may be equal to the pressure which is acting on the top of the diaphragm is P3, so which is equal to the pressure which is acting on the bottom of the diaphragm, that is the sum of the two pressures P1 and P2. So P3 equal to P1 plus P2. Now what happens here, the functioning here, when cooling load increases, it means in the evaporator the cooling load increases. What happens, the refrigerant evaporates at faster rate than the suction rate of the compressor. Okay, evaporation is taking place at faster rate. Why? Because the cooling load increases here in the evaporator. Here evaporation process is more compared to the suction rate of the compressor. Now the degree of superheat and its pressure in the bulb increases. It means the pressure in the bulb gets increases due to the temperature difference here. The more the pressure is created in the bulb, and more the temperature, so more the pressure in the sense, so this pressure it is acted on the top of the diaphragm. This pressure will, the liquid refrigerant, the pressure will be acted on the top of the diaphragm. Now the diaphragm will be pushed to the downwards. Now what happens here, due to the refrigerant in the bulb expands, okay, it get expanded. So this transmits the pressure at the top of the diaphragm through capillary. Valve opens more, so it is diaphragm is pushed to the downward, the valve gets opened more, and more the refrigerant will be sent inside, is admitted. Okay, now so it is passed through the, whenever it is admitted, diaphragm come downwards, refrigerant will passes to the evaporator here through this pipeline. At the top you can see from the top of the pipeline the evaporator will enter. Now what happens to the similar case if it is opposite, when the cooling load decreases, so evaporation rate is at slower rate. It's lower. Now the pressure drops and degree of superheat also decreases. Now the feeler bulb get cooled and it transmits the less pressure. So due to the contraction, what happens, the less pressure is created in that, so that pressure, less pressure which is acting on the diaphragm, so it is less compared to the pressures which are acting from the top bottom of the diaphragm, that is P1 and P2 pressures. So this what happens, it will create push to the upwards, the diaphragm moves upwards and the wall get the whatever the gap provided at the wall here, it gets reduces. So this continues till the spring pressure and evaporator maintains equilibrium with the feeler bulb pressure. So the spring pressure and whatever the remaining pressures, so P3 is equal to P1 plus P2 if it attains. So till that these differences will occurs, and the according to the load variations, the refrigerant will enters more or refrigerant will enters with less quantity, so depending on that kind of thing. Now so here coming to the next, that is a solenoid valve. So just it is a act like a passage here, it is a completely, so just observe the diagram first of all. It is a completely insulated one at all the sides, and you see the bottom side, so there is a refrigerant is entering through this part, and there is a valve along with a stem, plunger, valve and valve seat. So it will move upward and downwards. Whenever it is moving upward and downward, the refrigerant will open here, the passage will get open and the refrigerant will move, refrigerant will get out of that passage. And here there is a solenoid coil which is operated electrically. When it is get charged, so it will get attracted, the plunger will move upward. So when it get de-energized, the plunger will get moved to the downward. Here you can see the electrical supply, so a cover is provided over here, that is acts like an insulator. It just act like a passage. So it is a just not like a just a expansion device, but it will morely it is used for to avoid act like a safety device. Whenever the switch power gets off, it will not it will shut down the supply of the refrigerant to the next components. Okay, it stops the supply of the component, consider like it will not enter into the refrigerant. If it enters into the refrigerant, so all the refrigerant will enters and accumulated in the evaporator component, so it will create load on the compressor. Whenever it gets started, it will create more load on the compressor component. Okay, so right, just have a look regarding the points. So it is operated by control device similar to hand operated stop valve. So it is placed in between the condenser and evaporator, and hand operated stop valve means on switch on and off. It can be done manually, so it allows constant flow of the refrigerant or stops the flow. So if it whenever it opens, the constant flow of refrigerant take place. If you want to stop that, if the solenoid coils get de-energized or a power supply is off, then it can be the flow can be stopped by the valve which is coming to the downwards. Next, it's the insulated copper wire known as the solenoid coil, and a plunger is there which is iron armature which is placed inside the coil. The plunger consists of a stem with valve attached at the lower end. So when plunger moves downwards, closes the valve port by the valve. It means I already explained that when de-energized, so already it is a closed one. When the plunger moves upwards, the valve port open along with the stem and valve. Now valve can be opened or closed by energizing or de-energizing the solenoid coil. I already explained that when electric contact closes, energized solenoid coil pulls the plunger up and opens the valve. So it means energy supply is there, the plunger will move upward, valve gets opened and refrigerant will get close into the next component, that is to the evaporator. So de-energized, what happens opposite to that, plunger will drop downwards due to its self weight, it will falls down and it closes the valve completely. Okay, so this is regarding our class. So far we have studied all these topics, like evaporative condensers, comparison between water cooled, air cooled condenser, expansion device, types of expansion devices, capillary tube, merits, demerits, thermostatic expansion valve and solenoid valve. Okay, so here a few questions. Capillary tube cannot be used with So it cannot be used with. Answer is A, I think. High fluctuating load conditions, right? If you listen the class clearly, so you can understood what is that. Next, the frictional resistance offered by smaller diameter tube is directly proportional to. So answer is, the frictional resistance is directly proportional to the length. So more the length you are increasing, more the frictional resistance you are offering. Same, the solenoid valve is opened by, so whenever it get opened, whenever you are supplying the energy, energizing the coil. So the answer is A. Next, so when the plunger of solenoid valves move downward, the valve is, when the plunger of solenoid valve moves downwards, the valve is, what happens whenever it falls down? So it remains closed. Okay, so evaporative condenser uses dash as cooling. So we mostly concentrate on this. Evaporative condenser utilizes both the mediums, air and water, as a cooling medium here. So the answer is the C, that is air and water. Okay, next, so escaping of water particles along with the discharging air in evaporative condenser is prevented by. So especially we are used a eliminator, a crisscross type of structure. You have seen that eliminators are there. So the answer is B. Next, so these are the frequently asked questions, so you can note it down. Functions of expansion device. What is capillary tube? Explain the capillary tube with a neat sketch. Merits and demerits of capillary tube. Explain the working of thermostatic expansion valve with a neat sketch. Explain with a neat sketch the working of solenoid valve, and a few other questions regarding evaporative condenser. Explain the evaporative condenser with a neat sketch, and compare the water cooled condensers and air cooled condensers. Okay, so this is regarding today's class. We have learned a lot of topics regarding this evaporative condensers and seen some expansion devices, and those explanations we have seen. Okay, and comparisons of water cooled, air cooled condensers. So hope you have understood in this class, and in the next classes we will more concentrate on the evaporators. So thank you for watching, and we'll see in the next video session. So thank you.